your hands and your feet are what are called homologous structures. That just essentially means similar but different, right? They develop in a very similar way, but they serve different functions. The easiest comparison or another example I could make would be the testes and the ovaries. Those are both gonads. They are homologous to each other, but they obviously serve different functions. And the feet and the hands are obviously going to serve different functions, right? The hands are meant to be dexterous, right? You have a lot of dexterity. They're soft. It's easy to manipulate tools and things that you have inside of your inside of the hands, but the feet don't do that, right? Like your feet are not there to grasp things and move things. Now, obviously, under certain circumstances, we can kind of adapt them to do those types of things, but ideally that is not their function. Their function is to be stiff. The purpose of the foot is to be extraordinarily stiff, so when you land, it kind of stretches and maintains its structure, but then it helps reclaim energy. All of it is, intentional, because that is the most effective way to walk, to locomote, to actually run. Can you imagine you have these soft, gooey, hand-like feet and you're trying to go on uneven surfaces and terrain? It's just not going to make much sense. So these definitely have their differences. However, there is another difference that you see spoken about a lot on tests, and that is the number of actual bones in these, right? In the hand, you're going to have 8 carpal bones. So those are your wrist bones. But in the foot, you only have 7 tarsal bones, and the tarsus is going to be the region of the foot that we would call the ankle. However, the bones of the foot, those tarsal bones, are much more massive than the bones of the wrist, which makes sense because there's going to be a lot of support. And so our goal today is to just go over briefly the bones of your foot. And to do that, we're going to be using a 100% free Kenhub article. We've gone ahead and left a link down the description below, so be sure to check that out. In fact, you could follow along. It's going to make this a whole lot better of an experience if you get to see this and pause it and look at it yourself. Now, we have 2 views here in this image. We have a plantar surface, and then plantar view, I should say, and then we have a lateral view of the foot. This is a right foot, to be exact. Now, let's just orient ourselves even further actually before we get there. So you can see the fibula, which is going to be the more lateral of your crust bones, and then you have the tibia here. So when we're talking about the foot actually begins beyond the fibula and the tibia. So all of this would be considered the foot. And in fact, I'm going to go ahead and hit this button so then we can actually make this a whole lot bigger. And that is just going to make things easier for us to see things. Now, as we're looking at this, again, let's kind of divide this into the different regions, because if we were to use the Greek name for this would be, or Latin name, I should say, would be the pes. So this is the pes. So the pes means foot. But again, we have 3 different regions. So if we look beyond this right here, this is the lateral malleolus. This is part of the fibula. And if we look right here, this is where we can start to see it. I'm going to outline everything we see here. I am outlining the 7 tarsal bones. This is what's called the tarsus. The tarsus meaning ankle. And so these intertarsal joints, this is where your foot will actually kind of move around into a movement we call eversion and inversion. But then right here where we're going to see this bone right here is labeled the talus. The talus is the one tarsal bone that directly interacts with the fibula as well as the tibia. This is the ankle joint. So there's actually 2 different joints here. Well, there's actually multiple joints. There's the one ankle joint, which is where you get plantar flexion, which is like you're standing on the tips of your toes, and then dorsiflexion, which is kind of like your toes are coming up towards your nose, right? Those are happening here between the talus bone, which I'm outlining, and then the tibia and the fibula. When we're talking about inversion versus eversion, it's kind of like it's almost like you're driving your pinky into the ground, your pinky toe, or you're driving your big toe into the ground. Those are inversion and eversion. Those are happening in all of these intertarsal joints. So it's just, there's all these little 7 bones are just sliding around one another. All right, so then we look here and we can see this really massive bone. This is the calcaneus. Calcaneus is where the Achilles or calcaneal tendon is actually going to be inserting, right here. And then you can also see down here, this is where heel spurs can actually form, because this is where the plantar fascia, this really tight, dense piece of connective tissue on the underside of the foot, is going to reside. And if that thing gets stressed, it's possible that you can even grow some bone outside of the or on the calcaneus to try and relieve the tension, and then you have this little hook. Again, all right, that's what we call a heel spur. But this is the calcaneus, and calcaneus is Greek for heel, and in fact, talus is Greek for ankle. So these bones are two of the massive bones. But then we have this one here. This is what we call the cuboid bone. So the cuboid gets its name because it has a cube-shaped appearance to it. Is it the most cubic thing you've ever seen? No, probably not. But still, this is what we call the cuboid bone. This is on the lateral side. Then over here, we have another bone that we're outlining. This is called the navicular. The navicular bone, that means boat-shaped. So I always tell people, think of like the Navy, right? So every country has its own navy, or at least the ones who have water to take advantage of that. And it's just in reference to bones, to the shape of the bone being like a boat. In fact, I always tell people you could take the navicular bone, flip it upside down, stick a toothpick in it, put like a little napkin, and you could sail it down a little stream. It really does look like a boat, so it is a really well-named bone. And then we can see two of the three cuneiforms. So the cuneiforms, these are named after an ancient language. It's a box-shaped language. Someone looked at these three bones and was like, these are like box, cube, like almost like rectangular shaped. We're going to call these the cuneiforms. Now we can see two of them. There's a third one that's on the medial side, which is going to be called the medial cuneiform. This one right here is the intermediate cuneiform, and then we have the lateral cuneiform. So if you add those together, right? So we have the three cuneiforms. You then have the cuboid. You then have the navicular, and then we have the talus and calcaneus. That gives us 7 ankle bones or 7 tarsal bones. This is the tarsus. This is the tarsal region of your foot. Now beyond that, we have the metatarsals. Now meta in this instance means beyond. So these are beyond the tarsal bones. And there are 5 of them. And these are going to correspond to the 5 toes when we get to the actual digits. But we call these the metatarsals. Now, these are like deep to the really fleshy part, the thick part of your foot. There's no bending here, right? You can't like fold this over like you can fold your toes. It's analogous, again, remember when we're talking about homologous, actually, I should say, to the hand. It's like you have these metacarpals deep to your palm, right? Your palm can't fold. You bend on top of it or underneath it. But that's exactly what's happening here when we're getting into the foot. But one thing we want to also take note of is this right here. This is the tuberosity of the 5th metatarsal. And you see this in athletics all the time, something called a Jones fracture, which is where this little projection here can break off and fractures. And you see this again like in athletics quite often. And it actually has a pretty extensive recovery time, all things considered, which is never fun. But there are 5 of these metatarsals. And then we reach the digits. Now, the digits are going to be, once again, homologous to the hand. So it's really easy if you look at your hand to get a real solid understanding of how the foot is going to work too. Right? So your thumb has 2 individual phalanges or phalanxes. These are the bones inside of it. Well, so does your big toe. The other 4 digits, just like your fingers, have 3 bones inside of them. And so these 3 bones are going to have their different joints that are going to be able to bend. We call these the interphalangeal joints. But if we also come here, there's this knuckle here. This is what we call the MP joint, or the metatarsophalangeal joint. So this is where you're going to get like flexion of the toes, and then also we'll go into the interphalangeal, so it'll kind of like bend over just like that. But these are going to be joints that are going to allow for flexion, extension, and a little bit of abduction and adduction. Not a lot. Like you can try it right now. I'm trying it with my toes. You can spread them out. It's a little difficult, but it also is definitely going to be there. So if we were to add this together, let's kind of figure out how many bones are going to be in here. So we have 7 bones in the tarsus. We have 5 bones in the metatarsus, which again would then be, I can do math, 12? Is that 12? That's 11. No, it's 12. I can do math. All right, then we're going to have, if we count, 2 bones of the thumb and then an additional 12 bones in the other 14, in the other 4 digits, which gives us 14. So if we actually add this together, so 14 plus 12 would give us 26 bones of the foot. And so there are going to be 27 bones inside of the entire hand. But again, we have the tarsus, the metatarsus, and then we have the digits, or also you could say the phalanges of the foot. So again, this is a 100% free Kenhub article. We've gone ahead and left a link down the description below, so be sure to check this out. You can see that we put some premium features in there, like quizzes, which are, in my opinion, the best way to learn your anatomy. And then you'll also see a video, which again is a premium feature embedded at the top of the video. But I hope you learned something about the foot today. And if you did, go ahead and leave a like down below while you're checking out that article. You can also leave us a comment and let us know what other videos you'd like us to discuss in the future. But as always, it has been an absolute pleasure to hang out with you, and I will see you next time.